Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today we are going to learn aromatic hydrocarbons. So, what is aromatic hydrocarbons? An unsaturated cyclic hydrocarbon that does not readily undergo addition reactions. Aromatic ring system, the functional group present in aromatic compound. So, benzene, C6H6, a flat symmetrical molecule with a structure formula that is often formalized as that of cyclohexatriene. In other words, as a structure formula that involves a six-member carbon ring with three double bonds are present. Benzene itself is implicated as a cancer-causing chemical. Now see the structure, and this structure is one of two equivalent structures that can be drawn for benzene, and that differ only in the locations of the double bonds, 1, 3, 5 positions versus 2, 4, 6 positions. So neither of these conventional structures, however, is totally correct. So experimental evidence indicates that all of the carbon bonds in benzene are equivalent, identical. And these structures imply three bonds of one type, double bonds, and three bonds of different type, single bond. So an alternative notation for denoting the bonding in benzene, a notation that involves single structure is, in this circle in the ring, a structure for benzene, the circle denotes the electron associated with the double bonds that move around the ring. Delocalizations bond, a covalent bond in which electrons are shared among more than two atoms. The highly unsaturated carbon ring system in which both localized and delocalized bonds are present. The equivalent nature of carbon-carbon bond in benzene is addressed by considering the correct bonding structure for benzene to be an average of the two trienes structure related to this average. A structure situation is the concept that electrons associated with the ring double bonds are not held between specific carbon atoms. Instead, they are free to move around the carbon ring. Placing a double-headed arrow between the conventional structures and that are averaged to obtain the true structure is one way to denote the average structure. So, physical properties and sources. Physical properties: insoluble in water, good solvent for nonpolar materials, less dense than water, volatile, colorless, flammable liquid, burns with a sooty flame due to incomplete combustions. Several aromatic hydrocarbons are toxic. So sources: at one time coal tar, the main source of aromatic hydrocarbon, but now it's petroleum due to high temperature with a special catalyst. Toluene from heptane, situation in which the persons can be exposed to low-level benzene vapor. Benzene inhalations can cause nausea and respiratory problem. Inhaling gasoline vapors while refueling on the automobile, gasoline contains about 2% benzene, being around a cigarette smoker. So chemical reactions of aromatic hydrocarbons. Benzene undergoes substitution reaction, characterized by different atoms or groups of atoms replacing hydrogen atoms in a hydrocarbons molecule. Two important types of substitution reaction for benzene and other aromatic hydrocarbons: alkylations and alkyl groups from an alkyl chloride, substituents for hydrogen atom on the benzene. Most important industrial reactions of benzene: hydrogenation, bromination, or chlorination. Now friends, our target is fused ring aromatic hydrocarbons. Two carbon rings that share a pair of electrons atom, and aromatic hydrocarbons whose structure contains two or more rings fused together. Example: naphthalene, anthracene, and phenanthrene. All three are solid at room temperature. You can see the structure of naphthalene in different form. A white crystalline volatile solid with a strong coal tar odor. The solid is denser than water and insoluble in water, burns but may be difficult to ignite. In the molten form, it is very hot, exposed to skin must be avoided. Also, the vapor given off by the materials may be toxic, used as moth repellent, fumigant, lubricants, and to make other chemicals and for many other uses. Now you can see the naphthalene balls or mothballs. Naphthalene balls or mothballs. 7 star. Now friends, anthracene. You can see the structure of anthracene with different models. A colorless crystalline powder obtained from coal tar, used chiefly as a source of anthraquinone and alizarin. Anthraquinone and alizarin. Now you can see the different form of phenanthrene. Uses: phenanthrene can produce phenanthraquinone, polyester resins, alkyd resin, benzene, anhydride, and phenol. In paper making, it is anti-fogging agent of pulp. Paper making, it is anti-fogging agent of pulp. In medicine, it can produce alkaloids. In dye industries, it can be used in 2-amino phenanthraquinone, benzenthrone, and sulfur vat dyes. Phenanthrene can be used in the productions of the fuel jet of plant. Now, fused ring aromatic hydrocarbons and cancer. A number of fused ring aromatic hydrocarbons are known to be carcinogens, that is, to cause cancer. Three of the most potent carcinogens are 1,2-benzanthracene, 1,2,5,6-dibenzanthracene, 3,4-benzpyrene. Now, 1,2-benzanthracene. Benzanthracene is a crystalline aromatic hydrocarbons consisting of 4 fused benzene, produced by incomplete combustions of organic matter. Benzanthracene is primarily found in gasoline and diesel exhaust, tobacco and cigarette smoke, coal tar and coal tar pitch, coal combustion emissions, charcoal broiled foods, amino acids, fatty acids, and carbohydrate pyrolysis products, wood and soot smoke, and creosotes, asphalt, and mineral oils. This substance is used only for research purposes. Benzanthracene is reasonably anticipated to be human carcinogen. So, 1,2,5,6-dibenzanthracene is a polycyclic aromatic hydrocarbon and a known carcinogen. Dibenzanthracene has produced positive results in bacterial DNA damage and mutagenicity assay and in mammalian cell DNA damage, mutagenicity and cell transformation assay. 3,4-benzpyrene. Angular fused ring hydrocarbon systems are believed to be partially responsible for the high incidence of lung and lip cancer among the cigarette smokers because tobacco smoke contains 3,4-benzpyrene. Carcinogenic fused ring aromatic hydrocarbons share some structural feature. They also contain 4 or more fused ring and they all have the same angles in the series of ring. Fused ring aromatic hydrocarbons are often formed when hydrocarbons material are heated to high temperatures. So friends, these results compound are present in low concentrations, automobile exhaust, tobacco smoke, and sometimes in burned or charred food. Burned or charred food. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.